All right, welcome to our last video on quadratic word problems or real world problems. So this is nothing new, we're just putting all of our stuff into a contextual problem. So if you throw a ball, it will make a quadratic, fun fact. So after t seconds, a ball is launched into the air, reaching a height h feet given by the function h of t equals negative 16 t squared plus 90. So what that means is if I have a graph, and I have time on the bottom in seconds, and then I'm going to have height on my y-axis in feet. Okay, so if I throw a ball, I am starting at somewhere in the air, it's going up, and then it's coming back down to hit the ground. So let's answer some questions about this. Number one, how high is the ball when it is first launched? That's your y-intercept, which is going to be 0, 90, or just 90 feet. So that's always your last number. It's starting off at 90 feet. So if you wanted to, we've got 0, 90 for our y-intercept. Okay? What's the height of the ball after 3 seconds? Well, seconds is my x-axis, so I'm just going to plug in 3 for your t or for your time. So I would have parentheses, negative 16. Parentheses, plug in 3, squared, plus 64, plug in 3, plus 90. So let's go type it in. That's not right. Negative 16, close it, 3, squared, plus 64, close it, 3. Plus 90. So at 3 seconds, that ball is at 138 feet. Okay. Number 3, what is the max height the ball will reach? So max height is your vertex. So I am looking for my vertex. So if you'll notice, this equation is in standard form. To find the vertex, you need a formula from our last quiz, negative b over 2a. So I would have negative, my b value is 64, over 2, and then my a value is negative 16. So again, here's my b value, and then here's my a value. Oops. So negative 64 will be on top, and then 2 times negative 16, which will be negative 32. Divide those, and you'll get a positive 2. So your x equals a 2. So I know at 2 seconds, it is reaching its maximum value, but to figure out where, you need to plug in 2 into your original equation. So just like we did in number 2, I would have negative 16, plug in 2, squared, plus 64, plug in 2, plus 90. Now, since we did that hard work already, it is in my calculator. So I'm just going to go up, hit enter, and then scroll over and change that 3 to a 2. Scroll over, change this 3 to a 2. So my answer is 154. Feet. That will be its maximum height, aka your vertex, of 154 feet. So if I ever asked you how long does it reach its max height, it would take 2 seconds for it to reach its max height of 154. All right, last one. After how many seconds is the ball going to hit the ground before rebound? So rebound just means bounces back up. So hit the ground would be right here, which is your x-intercept. And so we learned in the video to find the x-intercept, we can use our quadratic formula. So my formula would be x equals negative b plus or minus the square root b squared minus 4ac divided by 2a. So let's look up here. My a is a negative 16. my b is 64, and then my c is 90. So let's plug these in. So I would have negative parentheses, my b, 64, plus or minus square root, your b, 64 again, squared, minus 4 times your a, negative 16, times your c, 90, all over 2a, so 2 times negative 16. Now, in a real-world problem, I don't care about leaving it in simplest radical form, so I'm just going to type this entire thing into the calculator. So let's do a fraction first. So alpha, y equals, enter, negative parentheses 64. Let's do the plus problem first. Square root, parentheses 64 squared, minus 4, parentheses negative 16, parentheses 90, parentheses all over 2 parentheses negative 16. Whole lot of typing. All right, so this ball will hit the ground at negative 1.1 second. Now that makes no sense. I can't have a negative 1.1 second. Okay, so one of them is negative 1.1, but that makes no sense. Okay, can't have negative time. So to figure out your other answer, I'm going to go back up, copy and paste all your hard work, scroll over, and change the plus to a minus. And hopefully this one makes sense. Boom. 5.1. That makes more sense. 5.1 seconds. So at 5.1 seconds is when your ball is going to hit the ground. So that would be our x-intercept, 5.1, 0, right there. Okay, so that is how you take your knowledge of finding a vertex or finding the roots or the x-intercepts to solve a contextual problem about throwing a ball. So if it ever asks when it's going to hit the ground or get 0, you're looking for the x-intercepts quadratic formula. If you're wanting the max height, you're wanting the vertex, you're doing a formula, plugging it back in. And if it wants to know where it starts, it's the y-intercept, which is the last number. So thank you for watching a real world quadratics. You can now work on your delta math. So I gave you 3 quadratic formulas, nice. I gave you 2 a little bit medium level, and then I gave you 2 a little difficult level quadratic formula, as well as solving square roots, sorry. And then I did give you an interpreting quadratics, like the problems we just did. So head to your delta math. If you have any questions, please let me know.